Okay, the following is just me writing out a few problems and solving them, and hopefully this will help you in how you're approaching the different problems. So, here we go. This is a problem from section 6.1, and the problem is 9x squared minus 4 divided by 3x minus 2. Now, in a situation like this, the first step is always to see if there's a common factor that you can factor out of the top or the bottom. So I'm going to look for a common factor. And 9 and 4, there isn't one. 3 and 2, there isn't one. There aren't x's in either of these, so there is no common factor. Okay? Now I need to go ahead and factor the top and then factor the bottom. So if I look at this, I notice that this is 9x squared and 4, and I recognize that as a perfect square and a perfect square. This is a difference of perfect squares. And so the square root of 9 is 3. The square root of x squared is x, plus square root of 4 is 2. And if you remember, if we have a difference of squares, it's the square root plus the square root, and then the square root minus the square root. So 9x squared minus 4 becomes 3x plus 2 times 3x minus 2. And that is divided by 3x minus 2. And I still cannot do any factoring on 3x minus 2. Now I need to look for my limitations. Remember, limitations are whatever would make the bottom of this rational expression 0. So I'll just set up my little equation and say that 3x minus 2 cannot equal 0. Plus 2, 3x cannot equal 2. Divide by 3, x cannot equal 2/3. Okay? And now I can rewrite this first equation. 3x plus 2, 3x minus 2, divided by 3x minus 2. And I recognize that this and this is the same. And so taking out a factor of 1, I can essentially cancel both of these, leaving it as 3x plus 2 divided by 1, which of course equals 3x plus 2. But remember, it's only 3x plus 2 if x does not equal 2/3. Because if x equaled 2/3, then this would have been undefined very early on, even before we could cancel these out. Okay? I'm going to move on to another one. This is a little bit more complicated. Y squared plus 10y plus 25 divided by y squared minus 9 multiplied by y squared plus 3y divided by y plus 5. Ah, there it is. Now you can see it. Here we go. So y squared plus 10y plus 25 divided by y squared minus 9 multiplied by y squared plus 3y divided by y plus 5. So the first thing that I notice is that this is a multiplication sign, and so I know I'm going to multiply this rational expression and this rational expression. When I multiply, you'll remember with fractions, it's just top times top, bottom times bottom. So I'll just put that in my head for now. And what I want to do first is see if there's anything that I can factor out. So I can't factor anything out of here or here, but I do know that this is the same as y times y plus 3. So I'll just set that right there. And now I need to factor every single term that I can, or every trinomial or binomial that I can. So let's look at this first. I recognize this as either a trinomial Or, if I was really paying attention, I would recognize it as a perfect square trinomial. So let's assume that I didn't. I'll know that the front needs to be y, and the back, it stands to reason that it's going to be 5 and 5 instead of 25 and 1, because I need something that multiplies together to give 25 and adds together to give 10. So I'll put 5 and 5. And remember, if this is a positive, then the signs are the same. If it's a negative, then the signs are different. Because it's positive, I know the signs are the same. So I look here and I recognize that those signs are both positive. And to check, I can simply FOIL, and that would give y squared plus 5y plus 5y, which is 10y, plus 25, which works. Now I'm going to divide that by this, and I recognize this is a difference of squares, so I will simply take the square root of the first term and put it up top, or in the front, and then the square root of the second term and put it at the back, and then a plus and a minus, and that's done. Now my multiplication sign. Now if you'll remember, I've already factored this much, and so I need to look in here and see if I can factor any more. I can't, so I'm just going to write y times y plus 3. And then I look at y plus 5, and I know that I can't do anything with y plus 5, so I just put it right there. Now, because it's multiplication, I know that all of this is going to be on the same line. Because it's top times top, bottom times bottom. So now I want to look, I put my parentheses there so I don't get confused. Now I want to look what the limitations are. I know that y cannot be anything that would make this, or this 0. So I know that y cannot equal a negative 3. It cannot equal a 3 because 3 minus 3 is 0. And it cannot equal a negative 5 because negative 5 plus 5 is, of course, also 0. So now I look at this and I realize that there are some things that I can probably cancel out. And remember, when I'm quote-unquote canceling them out, I'm really taking out a 1 because anything over itself is just 1, and anything multiplied by 1 is itself. So if I was looking at a times x divided by b times x, I would say, hey, that's the same as a over b times x over x. X over x is 1, so that's the same as a over b times 1, which equals a over b. So now I'm going to rewrite this all together. And if you'd like to put the y up front, you're more than welcome to. Divided by y plus 3, y minus 3, times y plus 5. Now I look and see if there's anything that is the same. Well, obviously I can take out a y plus 5 from the top and the bottom, and a y plus 3 from the top and the bottom, and that leaves me with y times y plus 5 divided by y minus 3. But remember, that's only if x does not equal negative 3, 3, or negative 5. That's my answer. Okay. I can tell that you are dying for another, so I will continue. Okay. X squared minus y squared over 4x plus 4y divided by 3y minus 3x divided by 12x squared. Now, I notice this is a rational expression and a rational expression, and they are divided by one another. So remember my rule whenever I'm dividing fractions, just like Mom taught us, dividing fractions, don't know why, flip the second and multiply. But we do know why, because technically we are multiplying by the reciprocal. But I digress. That's how it was taught, so we'll just go with it. But first things first, I need to see if I can factor anything out. I can't factor anything from here, but I can from here. So I'm going to rewrite this. Remember, it's better to take too many steps than not enough, because you don't want to forget things. Now if you'll notice, I took a 4 out of here and a 4 out of here, and so 4x divided by 4 is x. 4y divided by 4 is y. And then divided by, look, I can take a 3 out of each one of these, y minus x. And then that's just going to sit there exactly as it is. Now, if I want to, I can go ahead and factor this out. I recognize that it's a difference of squares. So I'm going to say that's x minus y, x plus y, divided by 4 times x plus y. And then I'm going to multiply this, which means I'm going to go ahead and flip them. So that's 12x squared divided by 3y minus x. So originally, it was like this, divided by, instead of dividing, I'm multiplying by the reciprocal, which is the same thing. Remember, dividing fractions, don't know why, flip the second and multiply. Now I can look and see if there's anything that's a repeat that I can cross out from the top and the bottom. If you'll notice, there are 2 x plus y's. I can get rid of those. And you'll notice 4 times 3 is 12. There's also a 12 up here, so essentially all of those go away because it would be 12 divided by 12. So I am left with x squared times x minus y divided by y minus x. Now, if you'll notice, these look very, very similar, but they're flipped. So if you'll remember, whenever we want to flip them, we just have to go through the process. So I'm going to rewrite it over here. X squared times x minus y. And remember, this process all makes sense. So I want to make it look alike. Okay? So I can't change the signs, but I can change where they're placed, because that's the commutative property of addition as long as the sign is connected. Right? So this is the same as negative x plus y, right? All I did was take the negative x and put it up front and the y and put it at the back. Now I can factor out a negative, making that x squared x minus y divided by negative x minus y. Remember, this is a positive divided by a negative, so it's going to give you a negative. Now, I see that this x minus y and x minus y are the same, so I can cancel them out. And so I have x squared divided by negative 1. Now this is correct, but it looks a little bit funny. And so remember, this is the same as a negative x squared over 1, which is the same as a negative x squared over 1, which is the same as negative x squared. And that looks a lot cleaner. So this is my answer. Now, if I go back up here, I will recognize that I do have some limitations. X cannot be 0, right? And x cannot equal a negative y, because if they did, they would cancel each other out. This would be 0, and then the whole world would explode. And if you'll notice, I flipped these right here, and that means that this becomes a bottom one too. So y cannot equal x, because if they did, then when it gets to here, this would be 0 on bottom. So remember, whenever you're dividing two rational expressions and you're checking for limitations, you have to look at the limitations of the bottom of both of them, and then the top of the second, because eventually it will become the bottom. Hopefully that didn't confuse you. Now, we're going to move on. I'm going to do 3 questions from section 6-2. 5 minus 7x divided by x squared minus 3x minus 10 plus 8x minus 3 divided by x squared minus 3x minus 10. So, whenever you're adding or subtracting fractions, you have to remember that the denominator needs to be the same. They need to have a common denominator. So if I look, I'll notice that these actually do have a common denominator already, which makes my life pretty easy. But let's go ahead and factor it just so we can see. So 5 minus 7x divided by, I can't take anything out, so I'm going to split up the x's, and I need something that multiplies to give me 10 and adds to give me 3. Multiplies to give me a negative 10 and adds to give me a negative 3. Well, I know that 5 and 2 have a difference of 3, so I know that that's it, but I also have to determine where my signs go. So there's 2 ways you can think of this. One is the bigger one, which would be 5, gets the sign. The second way is you can check, because your OI, or your outside inside, has to equal your middle. So negative 5x plus 2x equals negative 3x. So that works. And I'm going to add that to 8x minus 3 over, and obviously this is the same thing. Now I can actually rewrite it to say this is 5 minus 7x plus 8x minus 3 all over the same common denominator. Alright, now whenever you're at this point in the problem, you want to make sure that you distribute whatever sign is outside the parentheses to each thing. This is pretty easy because it's a plus sign, so we don't have anything to distribute. But imagine if this was a negative or a subtraction sign. If this was a subtraction sign, then I would have to distribute it to the 8x as well as to the negative 3, making this a positive 3. But since it's a plus, we don't have to. So I will simply say 5 minus 7x plus 8x minus 3 divided by x minus 5, x plus 2. Now, I'm going to add up my like terms. So I like to deal with the x's first. So negative 7x and 8x. That gives me 1x. And then 5 minus 3 gives a positive 2. And that, of course, is still divided by x minus 5, x plus 2. Now, before I cancel anything, let's double check what the limitations are. So here, x cannot equal 5. And here, x cannot equal negative 2. Okay? Now I can recognize that these are the same. Cancel them out. Remember, you can't cancel out x's if they're attached by a plus or a minus. I can cancel this out because it's one binomial, and the same binomial is down on the bottom. And so that leaves me 1 divided by x minus 5. Now notice that there's still a 1 on the top. This x minus 5 is still on the bottom of the rational expression, so it can't move up just because there's a 1 on top. So make sure to put that 1 there, because remember, x plus 2 divided by x plus 2 is not 0, it's 1. And that is, of course, if x does not equal 5 or negative 2. Sorry, I have to occasionally glance up there and make sure that I'm still writing within the view of the recorder. All right, we'll do another one. So this one is x minus 3 divided by 2x plus 6. And I'm adding it to x plus 2 divided by x plus 3. Now, one thing that we'll notice is we don't have to factor anything here, here, and here. But we do have to factor something here. So, it's okay, we all make mistakes. Just scratch through it, keep on moving. Now I can take a 2 out of each one of these, making it x plus 3. And then x plus 2 and x plus 3 cannot be factored. Now, the denominators are not the same, but I want them to be the same. So I need to find out the common denominator between these, and that's the least common multiple. If you'll remember in class, we talked about a boat, and that's something that has a seat for everything that's in this denominator, or has a seat for everything in this denominator. So, if I was looking at this boat, I would need to have, this stands for least common multiple, I would need to have a 2, right? I would need to have an x plus 3, and then over here, I would need to have an x plus 3, but I already have it. So, obviously, this is the least common multiple, okay? But now, I need to adjust to make sure that the denominators are the same. So, this one is the same, so I don't have to do anything to it, so I will just rewrite it as is. Okay? And now this one, I have to multiply it by a 2. If I multiply the bottom by a 2, I have to multiply the top by a 2. So this becomes 2 times x plus 2 divided by 2 times x plus 3. Okay? Now writing that out again, I have x minus 3 plus 2 times x plus 2, and now we're putting it all over the same common denominator. Alright, now I need to make sure to distribute not only my sign, if there is one, but also any coefficients. So this becomes x minus 3 plus 2x plus 4 divided by 2 over x plus 3. And then I can add up my like terms. So x and 2x gives me 3x. Negative 3 and 4 gives me 1 divided by 2 times x plus 3. Now, I can't factor this, and this is already factored, and nothing can cancel out, so this is my answer. But if you'll remember, we did have a limitation, and that is if x does not equal negative 3. Okay, this is the final one. (3x minus 2 divided by x squared plus 2x minus 24 minus x minus 3 divided by x squared minus 9. Alright, so first I want to factor each one of these. So I'm just going to rewrite that. I can't do anything here, so that's just 3x minus 2. But here I can factor this, right? I know it's x is up front, and then what times what equals 24 that has a difference of 2? Well, 2 and 12 doesn't work, and 1 and 24 doesn't work, and 8 and 3 doesn't work, so it must be 6 and 4. And remember, the big one gets the sign, and I know the signs are different because this is a subtraction sign. Okay? And that's minus x minus 3, can't do anything with that, divided by, this is a difference of squares, so it'll just be x plus 3, x minus 3. Now, at this point, if there's anything that I can cancel out, I would do it over here. And I would do the same thing over here. Is there anything I can cancel out? As a matter of fact, there is. I can cancel these. Okay? And so this leaves me with 3x minus 2 divided by x plus 6, x minus 4, minus 1 over x plus 3. Okay, now I need a common denominator, and that common denominator needs to be able to fit this, this, and this. So I would simply create a common denominator that has all three. Okay, so my common denominator is x plus 6, x minus 4, x plus 3. Let me look and make sure. Good deal. Now, let's look up here. What is this missing to get to here? It's missing an x plus 3. So that means I need to multiply it on top as well. So this becomes 3x minus 2 times x plus 3 minus, and what is this missing? It's missing both of these. So I would multiply this by x plus 6, x minus 4, and multiply this times x plus 6, x minus 4. So that would leave x plus 6, x minus 4. So just to recap, I factored everything, and then I saw that I could cancel something here, so I did. And then I found the common denominator, and then whatever each one was missing from the bottom, I multiplied it there and then on the top as well. Okay? Just, if you want to, you can do this at the end or you can do this in the middle of it, but you always want to be considering what your limitations are. Here I can see my limitations are a -6, a 4, a -3, and a 3. So I might just write that right here. And the more you do the limitations, the easier that it will get and the more natural it will become. So, let's get some room. Now, I need to foil this and foil this. I can't cross anything out because it's held together by subtraction, right? And you can only cross something out if it's only held together by multiplication. So, I'm going to go ahead and do the math here. That's 3x squared first, then outside is plus 9x, inside is minus 2x, and then the last is minus 6, and then minus x squared plus 6x minus 4x minus 24. And I could do that pretty quickly because if you remember, it was right here. Okay, and that is all divided by x plus 6, x minus 4, x plus 3. Now I don't have to multiply these together at all. So now I want to distribute any signs that are outside of these because I'm going to add up all the like terms, right? So I'm going to just say this is 3x squared, right? And then I can go ahead and add these. That's plus 7x minus 6. Now watch this. Negative x squared minus x squared, right? And then this also goes to here, making it minus 6x. Also goes to here, making it plus 4x. Then also goes to here, making it plus 24. Now, I'm going to save writing all this again, and I'm just going to try to put all my like terms together. So, do I have any other x squareds? Yes, there's one right there. So 3x squared minus x squared gives me 2x squared. Okay? Now 7x minus 6x is 1x. Plus 4x is going to give me 5x. Then negative 6 plus 24 is going to give me 18. This is, of course, divided by x plus 6, x minus 4, x plus 3. All right, now I need to factor this on top to see if there's anything that I can cancel out. So there's multiple ways to do this. Some people like to say 2 times 36 and then use that way. Some people just like to play around with it until they get the answer. I know this is going to be 2x and x, right? And now I need to think, what two numbers multiply together to give me 18, but when I put them in, they'll end up giving me a 5. Well, the most reasonable numbers that I can think of are a 6 and a 3. I'm going to put the 3 right here and the 6 right here. And I'm going to do that for a couple of reasons. One is I can't put the 6 right here, because if I put the 6 right here, then we would be able to take out a 2. And remember, we shouldn't be able to do that if we factored correctly in the beginning. And then I know the signs are all going to be plus. Yes. So let's just keep on going and see what happens. And we might get it right and we might get it wrong, and we'll figure it out. So this is 12x and 3x is 15x. Well, that cannot be right. That cannot be right. So let's see, what if we changed it around and made this 9 and 2? Could that work? Or 9 and 2? Could that work? I don't think that that could work either. In fact, if you think about it, I don't think that there's anything that I could multiply together to give me 18 that when it went through, it would add to something smaller than that. So what I'm going to do is glance over at the answer so that no one thinks that I'm trying to cheat you. And we recognize that this is a prime. And so my answer is simply 2x squared plus 5x plus 18 divided by x plus 6, x minus 4, x plus 3. And just because we couldn't cancel something out doesn't mean we did anything wrong. This is just the answer. And remember my limitations from the very beginning. So I'll write those down here. If x does not equal -6, 4, 3, and -3. All right, that is 6.1 and 6.2. So I'm going to stop this for now, and then we'll pick it up again with 6.3.